So for 3.8, now I recommend you go back and review 3.7 or question 3.7 because this one leads, or 3.7 leads right into 3.8. So 3.8, based on the preceding cross, what is the probability that an organism in the F2 generation will have round seeds and green cotyledons and be true breeding? So round seeds and green cotyledons, how many of those did we have? So that was 3 out of 16, right? 3 out of 16 were round and green. That was the phenotypic ratio, 3 out of 16 for, oh, not ratio, but 3 out of 16. Oh yeah, I guess that is ratio, but 3 out of 16 of the F2 offspring had round and green phenotypes. But so not all of those were true breeding. So true breeding means essentially that both the W's and the G's have to be homozygous. And so we can take a look, round and green. So this one right here, I want to use red here. So 1 out of 16 there. Let's take a look. This one is not true breeding, right? Because it's heterozygous there. So it would just be 1 out of 16 were round and green and true breeding. But what if, so you have this question on an exam, right? And you don't have time to map out this whole problem here. Is there a faster way? So let's take a look and see if we can take a shortcut here. So okay, so the question on the exam would be something like Mendel crossed peas having round and yellow cotyledons with peas having wrinkled seeds and green cotyledons. All the F1 plants had round seeds with yellow cotyledons. Like it would be just question 3.7, the beginning of it. And then it would be, based on the preceding cross, what is the probability that an organism in the F2 generation will have round seeds and green cotyledons and be true breeding? Well, you'd have to know, change the color of my pen here. So you would know that the F1, because you have this memorized, right? F1 is going to be big W, little w, big G, little g, and you're crossing that to another F1 or crossing it to itself. So same genotypes though. And we would do the forked line method, and you should probably already have the genotypic ratio for a monohybrid cross, like if you're just looking at the W's. So you should already have that memorized. So we'd say 1/4 big W, 2/4 big W, little w, 1/4 little w, little w. So we already know the genotypic ratio from this cross. We're just considering the W alleles, and we just map that out like this. Okay, and if you don't know that, go back and look at the first problem, or 3.7, and see where we got those numbers. So you have those memorized, and the question asked us, let me look at the question again. Probability that the organism in the F2 generation will have round seeds and green cotyledons and be true breeding. So we want to know how many, essentially, the probability, essentially, how many out of all the plants are going to have 2 big W's, so they're going to be round and green, and to be true breeding they have to be homozygous for both. So we just want the numbers that are going to be like this right here. So right away we can see that, okay, none of these plants are going to matter. The big W and the little w and the 2 little w's. So they're not going to matter at all. So we don't have to do the whole forked line method for all the possible genotypes and phenotypes. We can just focus in on the 1/4 plants that are going to have 2 big W's. And so for the G's, well, we already have the G ratios, genotypic ratios memorized too. So we know those are going to be 1/4 2 big G's, 2/4 big G, little g, and 1/4 little g, little g. And this is what we want. We're looking for only the offspring that have 2 big W's and 2 little g's. So we don't care about the quarter that are gonna the quarter of these big W homozygous plants that are gonna have 2 big G's. We don't care about those. We don't care about the 2/4 of these plants that have 2 big W's that are gonna have a big G and a little g. We don't care about those. We only care about the 1/4 that are going to have 2 little g's. So we multiply this one by this one, and we get 1 out of 16 2 big W's and 2 little g's. Okay, so that would be sort of the shortcut way to approach that problem. Again, if we went up here and mapped out, did the whole forked line method, we would see that, okay, yep, 1 out of 16 have the 2 big W's and the 2 little g's, just like we got when we used this shortcut method, and just look specifically at the genotypes we're interested in.